Our group will be presenting about an enhancement to Caesar Cipher. Our group members are Derek Pearson, Drew Williams, and Travis Sparks. So our paper information, we had two papers. One was called Enhancement Caesar Cipher for Better Security. It was published in the Journal of Computer Engineering in the May through June issue of 2014. And the second paper was a new modified Caesar Cipher cryptography method with legible ciphertext from a message to be encrypted. And this was published in the Procedia Computer Science in 2015. So an introduction, the goal of cryptography is to transform or encrypt plaintext into something unreadable by the sender. This is then transformed or decrypted back to the plaintext by the receiver. Anyone that has the plaintext without the decryption key will be unable to read the message. This allows only the intended recipients to be able to view the plaintext. So the Caesar cipher was first introduced by Julius Caesar more than 2,000 years ago. It was first used by Julius to communicate with his officers. It's a substitution type of algorithm. Each letter of the plaintext is replaced by a letter some fixed number of positions down the alphabet. It uses modular arithmetic to keep the shifting within the alphabet size.
So we're going to modify the Caesar cipher for our term project, and we used bits and pieces of a few different methods. The mixed monoalphabetic is a method in which each key is substituted with some random keys in the range of 26 letters in the alphabet. This algorithm replaces the letters used to send messages with another letter to the correspondence one by one. The easier monoalphabetic is keywords only uses a word or a group of words, then removed, deleted the same letter in the keyword, and then forwarded to the next letter with the last letter in the keywords, and so on in sequence in the 26 alphabets. The general monoalphabetic, the general specification of encryption is determined by looping the column position corresponding to the number of different alphabets in the keyword. Our modification breakdown is, achieved by replacing the alphabet in two parts. Vowels are only replaced by vowels, and consonants are only replaced by consonants. The vowel alphabet consists of 5 vowels, and the consonant alphabet consists of the 21 consonants, and Y is always considered a consonant in our modification. For our key generation, 2 keys are generated from the input length of the string. The vowel key is generated by taking the length of the string modded by 5 for 5 vowels in the alphabet, and the consonant key is generated by taking the length of the string mod 21 for the 21 consonants. The input for our program is a plaintext string, and all the spaces are then removed, and the output of the program is a ciphertext where consonants have been replaced by consonants and vowels by vowels.
Okay, so now a short demonstration of our program. So we take in a message through this read line, and then we have 2 functions, an encrypt and a decrypt. So they each take in a key and then the plain text or ciphertext. And so the key is broken down into a constant key and a vowel key. So then if it's a vowel or a consonant, we use the consonant key to figure out the Caesar cipher, and then for the vowel key we use that if it's a vowel. And then for our decrypt, we break down the same exact key and then do the reverse process for that. So then we can see how this works. Type in our message. And then you can see how the plain text, we strip the spaces and make it all lowercase, and then you can see the resulting ciphertext, and then finally it gets decrypted back to the plain text.